Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Let f from a to b and g from b to c be two functions. F is from a to b, a is the domain, b is the codomain, g is from this same b to c. So the codomain of the function f is same as the domain of the function g. If we have two functions like this, defined in this specific way, then GOF defined from A to C is the composition of f and g. It is from A to C, composition of f and g, defined as GOF of x is equal to g of f of x. Let's see what does it mean. First of all, this composition of the two functions, this new function GOF, will take the domain set A and the codomain set C. So GOF is defined from A to C. And how is it defined? For any x of the set A, the image in set C is obtained through this process. GOF of any x is G of f of x. G of f of x. Let's take an element. Say x is in set A. Any x I'm taking in set A. In order to find, how do you get the image? If x is in set A, f of x will belong to set B because f is a function defined from A to B. So image of x under the f rule, which is what we call fx, f of x will fall in the codomain of the f, which is set B. So f of x is in set B. Now, if f of x is one element in set B, surely it will have an image under the next rule g. So g of this number is possible. G of this number will be found in the codomain of the g function, which is set C. So the image of f of x under the g rule, which is called g of f of x, g of this element, g of f of x, that will be found in the set C because that is the codomain of the rule G. Now, if you take an x in set A, f of x falls in set B. Since it falls in set B, its G image will be falling in set C. So G of f of x, this element, will be found in set C. G of f of x is what? Denoted as GOF. GOF is a single rule. So which element will be taken to which element, we will be able to obtain through this process. GOF of 13, if you want, you go and find 13's image under f, that is f of 13. Then whatever f of 13 comes, its image under g of that number you find, that will be the image of 13 under this rule. This is called composition of two functions. Let f is defined from set 1 2 3 to set 1 2 5 and g is defined from set 1 2 5 to set 1 3, given as f is equal to set ordered pair 1 2 3 5 4 1 and g is equal to set 1 3 2 3 5 1. Write down GOF. Let's try to understand the question itself. F is a function defined from set A to set B. I call this set 1 2 3 set A, set 1 2 5 set B. This is f defined here. And g is a function defined from set 1 2 5 to set 1 3. Notice that these two sets are same. That I am calling set B. So f is defined from A to B, g is defined from B to C. And G is also given in the roster form. All ordered pairs are given. Which element related to which element it's given. No rule is given to us. G rule is given in the roster form. F also is given in the roster form. Let's try to get their arrow diagram. 1, 2, 3, 5, 4, 1. 1, 2, 3, 5, 4, 1. 1, 2, 3, 5, 4, 1. This is the arrow diagram. And for G, 1, 3, 2, 3 and 5, 1. 1, 3, 2, 3 and 5, 1. That is what given to us. Now we need to check whether we need to find out the GOF. Write down GOF. As we have already seen the definition of GOF, if f is a function defined from a to b and g is a function defined from b to c, then GOF is a function defined from a to c. How? GOF of any element is G of f of x. So, here x should be any element from this set A. X can be 1 or 3 or 4. There are only 3 elements in set A. GOF is defined from A. And the images we should be getting in set C. So, we will go on calculating each image. GOF of 1, GOF of 3, GOF of 4. These are the 3 images we need to get. Let's go by the definition. GOF of 1 means G of f of 1. That is what the function says, the definition says. GOF of 1 is G of f of 1. Let's see what is f of 1. F of 1 is 2. Image of 1 is 2. So here I would write 2 because f of 1 is 2. So G of 2, f of 1 is replaced as 2. Image of 1 under f rule is 2. Now we need to get what is G of 2. What is the image of 2 under G rule? 2 was related to 3. So we get the answer 3. So under the GOF rule, we got one pair, 1, 3. 1, 3 is an element, 1, 3 is a pair in the GOF. Next, we need to get GOF of next number 3, which is G of f of 3. Go and see what is f of 3. F of 3 is 5. From where? From this roster form. Image of 3 is 5. So write what is f of 3 here, 5. So the equation, the step becomes f of g of 5. And what is g of 5? G says 5 has the image 1. 5 has the image 1. So the image is 1 here. So GOF of 3 is 1. So 3, 1 is next pair we can put in this roster form of GOF. And the last we need to get the image of 4. GOF of 4 is G of f of 4. And f of 4, how do we get f of 4? F of 4 is 1. The function given to us says f of 4 is 1. So here this step becomes G of 1. Now what is G of 1? G says image of 1 is 3. So here the step goes 3. That means the element 4 has image 3 under the rule GOF. So we join that also in the roster form. So we were asked to find out GOF function. GOF function is being written as roster form now. In the question also, the functions were given in the roster form, listing down the possible ordered pairs. That is what called roster form. So here we listed down the ordered pairs that will belong to this new function GOF. Hence, this set of ordered pairs is the GOF, composition of two functions.